All right, what's up, Joel? So today we're going to be learning about transformations. We are on our last unit. And so this is pretty exciting, and I think you're going to find this last unit pretty nice compared to our other units. It's kind of ending on a high note, on a pretty simple note. So if you have any questions, let me know. So there are three or four different kind of transformations. There's translation, rotation, reflection, and dilation. Today I'm specifically going to focus on translation. So if you have any questions about what this is, please let me know. So a transformation is something that is changing. So in geometry, there are specific ways to describe how a figure is changed, and I already listed those below. And so renaming transformations, it is common practice to name a shape. It is a common practice to name transformed shapes using the same letter with a, little quotation symbols, right? And we actually call these prime, okay? And so we use prime to describe a moved figure. And so if we move A or rotate it or reflect it or dilate it, we are going to call it A prime, B prime, C prime, and D prime. So we have figure A, B, C, D, but we also have figure A prime, B prime, C prime, and D prime. So a translation slides an object a fixed distance in a given direction. So the original object and its translation have the same shape and size, and they face in the same direction. And so nothing happens with our shape besides the fact that we are literally just sliding it, okay? We're not changing the size, we're not changing the shape, we're not changing what it looks like, we're just moving it. And so let's examine some translations related to coordinate geometry. And so we're going to use coordinate geometry a lot when we're working at transformations, specifically just translation today. The example shows how each vertex moves the same distance in the same direction. And so if we're moving A 6 units to the right, so 1, 2, 3, 4, 5, 6 is now going to be at 2 and 5. We also have to move our coordinate B 6 to the right as well as C 6 to the right. And so we have triangle ABC, and then we move it 6 units to the right. And so now we have A prime, B prime, and C prime triangle. And we call these points our vertex. So each vertex slides 6 units to the right. So A is a vertex, B is a vertex, and so is C. In this example, the slide moves the figure 7 units to the left, so it's a little off, and 3 units down. So if we're looking at A, just regular A here, we are moving 7 units to the left, 1, 2, 3, 4, 5, 6, 7, and 3 units down, 1, 2, 3. And we move that vertex A, 7 units to the left, 3 units down, which means we also have to do that to our vertex B, C, as well as D in order to keep those locations the same, not change our shape, and keep it the same. So we are going to write the points. What are the coordinates for A, B, C, D? So A's at 2, 4, B's at 4, 4, C's at 5, 2, and D's at 2, 1. What are the coordinates for A prime, B prime, C prime, and D prime? Well, A is now at negative 5, 1. B is now at negative 3, 1. C is at negative 2, negative 1. And D is at negative 5, negative 2. And so you have to think about this. How did the transformation change the points? And so if we're looking at just our x, think about it. If A is at 2, x is 2, and now it's at negative 5, in reality, what we're doing is we're taking 2 and subtracting 7 from it, and we're getting negative 5. Right? That's all that's happening with our points. And then we have to look at our y and think about our y is going down. Let's see, 1, 2, 3. So 3 units, right? Is that correct? Let's look. Yep, 3 units down. And so how we would write this is we would do, let's see if I put this animation in. I believe I did. My figure slides 7 units to the left and 3 units down. And so what that means, Joe, is that we're literally going to go x minus 7 for all of our vertices, and then y would be minus 2. And so if you look at this, 2 minus 7 is negative 5. 4 minus 3 is 1. 4 minus 7 is negative 3. 4 minus 2 is 1, or 3 is 1. 5 minus 7 is negative 2. 2 minus 3 is negative 1. 2 minus 7 is negative 5, and 1 minus 3 is negative 2. And so that is how we would kind of look at this if we were trying to make it into a formula in a way. Okay, that's all I'm going to teach you today. I'm not going to teach